Now here is the first question. Evaluate the following expressions. So in the first one we have to find out log of 64 to the base 2. Now if you recollect, the meaning of log is we have to find out 64 is what power of 2. Now we are already aware that 2 raised to 6 gives us 64, isn't it? So therefore log of 64 to the base 2 is nothing but equal to 6. Let's do the second one, in which we have to find log of 1 upon 27 to the base 3. Now let's ask the question, what's the connection between 27 and 3? So we come to know that 3 cube is 27, right? But we have 1 upon 27 and not 27. So therefore clearly if we make the index negative, we will get the reciprocal on right side. So therefore 3 raised to minus 3 gives us 1 upon 27. Hence the answer is minus 3, right? Of course we will see how to write the negative logarithms later. Now log of 16 to the base 8. Now this may look bit odd because although 8 2's are 16, but it's not the multiple. We have to find the index of 8. For that, let us try to find out some convenient number between 8 and 16, right? If you look at 16, then we are aware that 16 can be written as 2 raised to 4, correct? But somehow we have to write 16 with 8 as the base, okay? So this 2 we can write as cube root of 8, isn't it? So let us write it as 8 raised to 1 by 3 and whole raised to 4. So thereby, by using rules of indices, we can write 8 raised to 4 by 3. So we have written 16 as some power of 8. So therefore the answer is 4 by 3, right? Let's go ahead and solve the next question. Now here we have to show that the expression given on left hand side is equal to log 2. If you observe, we have not given the basis, so it just means that it does not matter what base is to be considered in this example, right? So let us start off with simplifying the LHS. We have the first term, that is log of 75 upon 16 minus. Now this 2 can be sent on top of 5 by 9 as the exponent, so that can be written as log of 5 by 9 the whole square, right, plus log of 32 upon 243. Okay, now that equals log of 75 by 16 minus log of 25 by 81 plus log of 32 upon 243. So here we see that there are two logs which are positive, so they can be added, and the third term is negative. If you remember, we had seen the property, that is log of m plus log of n is equal to log of m into n. So wherever logs are added, we multiply those numbers, and wherever logs are subtracted, we divide. So together we can write 75 upon 16 into 32 upon 243, correct? We multiply the two numbers where logs are positive, and we divide by the number where log is negative. So therefore that gives us 25 upon 81. And on cancelling and simplifying, we will finally get the answer as log 2, which is the required right hand side. So for that solves the problem, right? Let's go ahead and see another type of question. Now here we are given an equation that involves logarithms, and we have to solve for x. That means we have to find that value of x for which this equation is valid. Okay. Now since we are given this, we can definitely go ahead and simplify it. If you see the properties of logs, that is log of one number plus log of another number, we can merge them and say that that must be equal to log of the product of two numbers. So that is log of x plus 3 into x minus 3 must be equal to log 16. So therefore log of x square minus 9 is equal to log 16. So if logs of two numbers are same, clearly the numbers themselves should be same. So that gives us x square minus 9 is equal to 16. So x square is equal to 25 So therefore we can say at this step x is equal to plus or minus 5. But here comes one very important point. Although we have got two values of x, they are in the context of an equation involving logarithms. So we have to verify and validate whether both of the values are allowed to be the answers. Now if you take x equal to 5, then we will get x plus 3, that is 5 plus 3, that is 8. So log 8 plus 5 minus 3, that is 2. So that is log 2. So we have log 8 plus log 2 is equal to log of 8 into 2, that is log 16. So x equal to 5 correctly satisfies the given equation. But if you take now x equal to minus 5 and verify, right, you will get the first term as log of minus 2 and the second term as log of minus 8. Here we observe that the log is taken of a negative number, which is not allowed by the definition of log. Right? See, we cannot just simply go ahead and say that minus 2 into minus 8 is still 16, so it is valid, but it's not, because it does not satisfy the definition of logarithmic function. So therefore x equal to minus 5 is not the answer, and x equal to 5 is the only answer of the given equation. Right? Let's move on and see one more interesting type of question. Now here we have to prove that 1 upon 4 is less than log of 2 to the base 10, which is less than 1/3. Now to prove this question, we follow a slightly different approach. That is, what do we do is, we break this question into two parts. That is, first we show that 1 upon 4 is less than log 2 to the base 10, and we also prove that log 2 to the base 10 is less than 1 upon 3. And then if we prove these two cases or these two inequalities, then merging them we would have proven the required inequality. Now here to prove this, we follow, as I said, a different technique. That is, we calculate backwards. That is, if you want to prove, let's consider the first part, that 1 upon 4 is less than log of 2 to the base 10. That means what we'll have to prove is 1 less than 4 times log 2 to the base 10, isn't it? I take 4 to the other side. So that in turn equals, we have to prove that 1 is less than. Now on right side I can take 4 on top of 2. So therefore we can write it as log of 2 raised to 4. So that is, we have to prove that 1 is less than log of 16 to the base 10. That is, what we have to prove is, if we take 10 raised to 1 on left side, we have to prove that 10 raised to 1 is less than 16 by taking the help of definition of logarithm. That is, we have to prove that 10 is less than 16, and here we already know that 10 is guaranteedly less than 16. So therefore, writing backwards, we can easily say that we have proven 1 upon 4 is less than log 2 to the base 10. Now in exactly similar manner, we prove the other half of the inequality. So that is, we have to prove that log 2 to the base 10 is less than 1 by 3. So that is, we have to prove that 3 log 2 to the base 10 is less than 1. That is, we have to prove that log of 2 cube to the base 10 is less than 1. That is, we have to prove that log of 8 to the base 10 is less than 1. That is, we have to prove that 8 is less than 10 raised to 1, right? That is, we have to prove that 8 is less than 10, and we know that 8 is definitely less than 10. So therefore we have effectively proven the other inequality also, and hence merging both of the inequalities, we can say that we have proven the required given inequality.